Okay, good morning and welcome to today's Hawk Ridge Systems Wednesday webinar product demo. We'll go ahead and get started. First of all, my name is Glenn White. I'm Simulation Product Manager here at Hawk Ridge Systems, and I oversee many of the different analysis products that we have available for SOLIDWORKS. Today's presentation is on SOLIDWORKS Plastics, our injection molding analysis package. It's going to let you make early predictions of potential manufacturing problems with injection molded plastic parts. Okay, so over the next 45 minutes, I'm going to discuss SOLIDWORKS Plastics, which is the injection molding analysis tool for SOLIDWORKS. As a general statement, what an injection molding analysis tool is looking to achieve is it's looking to simulate the mold filling process that occurs when you take an injection mold tool, put it on a molding machine, and hit go. Looking to simulate that as closely as possible such that we can find and detect potential issues while the object or the part is still in a design phase or a tool design phase before we've actually gone ahead and commissioned the tool and cut metal. There's really obvious benefits to having that sort of insight ahead of time. Obviously, one of the biggest contributors to the effectiveness of a plastic mold or a plastic part is the part design itself. Anyone who's working with injection molding has seen plastics design guides that give you rules of thumb for the wall thickness and the size of ribs and transitions from thin to thick wall sections and stuff like that. All those rules are in place to minimize the effect of potential molding issues. However, there's times when the rules of thumb just aren't good enough. They don't give a detailed enough result. And there's definitely scenarios in 3D parts where it's hard to find a rule of thumb to apply. But we can really influence the ease with which we can mold a part and the cost at which we mold it in the part design phase. And as we design the tool and its layout and the number of cavities we have, we also have a lot of input there into how we can control things. So by running injection molding analysis, we're able to detect potential short shot, weld line, air trapping issues while the part and the tool is still in a virtual phase, rather than finding those issues when we run our first sample off the tool, having already invested $10,000 to $50,000 in the tool. That's a bad time to find out about an issue. Finding out about an issue a lot earlier obviously has a much greater benefit. There's a survey of injection molding, the injection molding industry, that listed the average number of rework cycles for a typical plastic mold throughout North America is 3 rework cycles, which basically means, on average, take a tool from the tool designer, tool manufacturer, run the first shot, find an issue, send it off for rework, bring it back, run it again, send it off, bring it back, run it again. That's the national average, is 3 rework cycles. Our goal of plastics is to get that down, because each one of those rework cycles costs money and takes time. And if you've got a product to launch and the thing that's holding it up is the injection molding tool, that's not a good look and something we want to try and avoid. But plastics is a tool to make decisions early, to figure out where those problems are and develop solutions of them before we've even touched a piece of tool steel. And plastics is, in terms of how we look at our products, We consider it an analysis product because it is running equations on a meshed 3D space. Right? But in terms of its usability and how you go about using it, it's a true designer's tool. It's not an analyst tool. It's making smart decisions in the background so that you get the right answer, that the inputs that you provide to the software that we'll show you in a minute are the same inputs that you're considering as a plastics part designer or as a mold designer. Okay. All of our SOLIDWORKS simulation analysis tools have three kind of key brand strengths that we talk about. One is that they're all easy to use. Right? About the inputs being designer-centric inputs. We're not going to worry about the analysis detail too much. The software is going to do that intelligently for us, and we're going to come up with a good answer. It's completely integrated in SOLIDWORKS. We never want to be exporting our part files to another piece of software and manipulating them there. Okay? Having things integrated in SOLIDWORKS means I can make a design change to my part and analyze the effect of that change instantaneously. I can hit run, go through the analysis process, and see the effect of the change I just made. And the last point is that we're a single source solution. Here at Hockridge Systems, in conjunction with our partner SOLIDWORKS, we can provide support on both the CAD geometry modeling piece of it as well as any analysis capability. One phone call, one email address, we can help you handle those issues. So we're never going to defer you to another partner and say, I'm sorry, we can't help you there. That's an injection molding issue. We have teams in-house that can handle it. So, SOLIDWORKS Plastics comes in 3 packages. And in a broad sense, the packages are kind of based on different kind of use cases, right? So the first one is Plastics Standard. Okay, that's going to analyze the mold filling portion of the injection molding process, basically from having an empty tool cavity to a full tool cavity. It's going to give you an idea of if you're going to be able to fill the cavity with the settings you have. You don't want to get a short shot. It's going to give you some insight into location of sink marks, air traps. It's going to let you experiment with different gate positions to see which one's going to fill the part most effectively. We sometimes refer to that as being the tool that's best suited for the plastic part designer. For someone that doesn't have a huge amount of control over the mold design or the molding process, right? But wants to make sure they've done the smartest things in terms of part designs for ease of filling, and wants to check for kind of basic defects and plan out where they're going to put the gate. Okay. There's definitely situations where a part designer may want higher level capability, but that's kind of the general sense. Plastics Professional, we're kind of aiming a little more at someone that has a little more control over the tool layout, the tool design, over the molding processes. We're going to analyze the fill and the pack process of the analysis, and we can get it to multi-cavity layouts. All right, several instances of a part in a tool, or maybe a family tool with different types of part laid out into a tool. One of the key things we can do there is do run and balancing. Right, if parts have different volumes and shapes, they're going to fill differently. We want them ideally to fill at exactly the same time, so we fill evenly, and we control the size of our runners and our delivery system to enable that. And we also got some advanced analysis, advanced molding types, talking about co-injection, talking about over-molding, talking about analyzing fiber directions and things like that. Okay. The top level is Plastics Premium. That's going to analyze the effect of warp on the tool, on the part. Okay. To understand how a part's going to warp, you've got to fill it, you've got to pack it, and then you've got to release it into ambient air. And each of those phases will have an input to whether and how much a part is going to warp. And we're also able to analyze and model the cooling system of the tool. We want to get really into the design of the cooling system, a really detailed and accurate understanding of the cooling processes. We want to get into that plastics premium phase. Those are the three tools as they break down. And of course, as you move up the packages, all the capability of the low-level packages is included. So let's start with SOLIDWORKS Plastics Standard, and let's look at an example. Right? We're answering basic questions. Will my part fill? Where are the weld lines? Where are there air traps? We can do the filling phase. So let's take a look at a sample. Now, what I have here is a smoke alarm case, right? It could be any injection molded plastic part. My process to set up a plastics analysis on this is pretty straightforward. All right, first of all, I turn on SOLIDWORKS Plastics as an add-in. Tools, add-ins. I have a license of SOLIDWORKS Plastics that'll appear in my list. I hit OK, and I now have a plastics tree available to me, basically an analysis tree. The things I need to define in here are pretty straightforward. I start off by defining a mesh grid. Okay. Process to put together a mesh is really the only sort of analysis-specific thing that we need to do. But we have to turn this 3D shape into a grid that the software can analyze. So typically what we do is set some sort of size, right? And we can tell the software to go mesh that. Very fast, automatic mesh tools. Just go a bit bigger. I've got a fairly coarse mesh that I'm starting with here. As you can see, it's done things like not very accurately describe these circles. This was a fairly detailed port here that it might be kind of approximating a bit too coarsely, but one of the neat things we can add is the ability to overlay control, right, to refine around detail and things like that. And there's an automatic setting that I really like. Basically going to refine the mesh where it needs to based on its own decisions, and you can see we get better approximations of these shapes, of these details around the model. And I can tweak this to get exactly what I'm looking for a real analysis. I'd probably go a little bit finer, but for the purposes of this process, that's going to be just fine. Aside from that, I'm looking to identify the material that I want to work with. Let me just confirm what material is best. So I have an extensive library here of materials that are available to me, either sorted by, there's about 5,000 materials in the library. I just sorted by type, where I've got my ABS and my polycarb and polypropylene, polyethylene, sort of things, all sorted by the manufacturer, the plastic supplier. Okay, I've got great search tools that I can use to find different things. Right, I can track down, but in general, and I've got the ability to add my own materials to this environment if I wish to. I'm just going to switch back here, and let's assign a polycarbonate material to this shape. So it's just a case of finding by family, come down to PC for polycarb, right? I could pick a specific grade, all these polycarbonate materials, lots of them there, or I can go for like a generic, an industry average across polycarbonate. Maybe when I'm at that initial phase of deciding between the basic type of plastics, this might be something I'd explore. I can shoot for a filling time, right? Controlling the rate at which I fill is going to influence the pressure needed to fill. So I can adjust these things. But I can also control melt and mold temperatures. Out of the box, these are going to be directly read from the data sheet for this material, right, from the library of information. So see these reference values. I can manipulate them to try higher or lower to resolve certain defects. We'll stick with the default for now. And then I can go ahead and define the location at which I'm going to gate the part. Right? Where am I, and the point is quite small there, where am I going to provide plastic to this part? Where am I going to fill from? Right? And this is often one of the key criteria. You don't want that gate on a show surface or surface the customer is going to see, but you need to position it in a place where you effectively fill the tool, often in the middle. You can have multiple gates. You can have the software give us a suggestion based on the 3D geometry where the best place for multiple gates is. So we're going to make an assumption there and set it to run. All right, I've set this running here, but you can see the results starting to animate on the screen of the fill process. 40% of the way through, and that graphic is updating. But we can already start to maybe sense a problem if we know what we're looking for. With this relatively thick section through the outer walls, my flow front is advancing faster than it is through the thinner section in the middle. So it's going to mean it's going to fill, and then these ribs are going to start to fill backwards. The problem that's going to create is potential for, will create weld lines across these ribs. Weld lines are where two flow fronts, plastic flow fronts, come together. And the problem with having weld lines on those ribs is that they're likely the thinnest portion of my model. Having a weak weld line at that place could predispose this part to failing if it's at that position, if it's subjected to any sort of load. If someone's pushing on this to try and put it in place, I'm kind of molding in a weak spot on the model right through the middle of the ribs. Weld lines are likely going to be unavoidable with this shape, but I would love to position them in a place where they're somewhere in the thickest, stronger section of the tool. So when it's done, right, it's about a 3-minute process or less to do that analysis. When it's done, I have an animation of the filling process. You can see kind of each of these weld lines forming. Right, so that's an issue. You can have the software flag weld lines on the product. I'm not so concerned about these ones through the thick region, but these ones through the ribs and through the circular ribs are definitely a concern. And all the time as I'm flicking through different results, I'm getting this feedback on the right. This is my results advisor. It's basically telling me what the plot I'm looking at means, what I should be concerned about. This is just general information. It'll show the same for whatever weld lines. But the top portion is results, is analysis specific, right? It's reporting some key information. Hey, here's the peak pressure that you achieve. You compare that against the capacity of your mold machine. It's giving me some design advice. I could get away with reducing the part thickness and still have a moldable part. Got no plastics degradation. It's got some potential, cooling and temperature gradient issues. But in general, a green light suggests it's a fairly easy, smooth filling process. Orange or red lights are more problematic. There's other data available to me, the pressure profiles throughout the molded part at the end of fill. We then go on to packing from here. So those pressure profiles make a difference. All right, temperatures at the end of fill throughout the model. Sometimes an early assessment of cooling time. Right, how long is it going to take this part to cool to ejection temperature? This right now is based on an assumption that the mold wall is maintained at the specified mold temperature. But we're looking at 47 seconds of fill time, of cool time on this part, which is huge. And it's, as you can see, totally due to the big thick section, which we can kind of get a sense of. We can get an early look at the location of any sink marks. Not really seeing too much of an issue there. So we can look at that. Okay, that's all great. Let me know if you have any questions, but that's basically a quick run through an analysis process using SOLIDWORKS Plastics Standard. Now the beauty of having this stuff in SOLIDWORKS is that you're always connected to your geometry. Right? We have wall thicknesses and layout information that's built right in to this model. I could make an adjustment to a parameter and hit run and see the effect of that parameter change very, very quickly. We can also use SOLIDWORKS tools like configurations, and I have some variations on this model that try out some different options. They're just sorted as configurations. I can kind of duplicate plastic studies for each configuration to keep them all independent. But I have one here where I try and solve the weld line issue and the cooling issue by thinning out the outer section. Right, I've already executed this, I've already run it, just load those results. When I animate these results, I still see